This is a power of a repeated multiplication question for a 2x2 matrix, which we're given in the problem. And we also have been given the p, so hopefully this p to the negative 1 AP does something nice for us. It allows us to get this power well. So just before we move forward, we should get the inverse matrix. And using whatever method you like for this, we should be able to find that this is negative 3, negative 2, and negative 4, and negative 3. So that p to the negative 1 AP is going to be this inverse. And then I'm just going to go ahead and multiply a and p using the matrices that were given above. So I'll have a negative 30 plus 36 is 6. Or my bad, that's negative 30 plus 24, which is negative 6. And 40 minus 36 is 4. And then making our way along the bottom, 18 minus 14 is 4. And negative 24 plus 21 is negative 3. And so if you're kind of paying attention, you can see that the first column is exactly negative 2 of the first column of P. So that's an eigenvector. And the second column is exactly the same. So that's the eigenvector for 1, because the multiplier is 1. And then we'll just go through and do this multiplication from here. So I get 18 minus 16 is 2. And negative 12 plus 12 is 0. And then 12 minus 12 is 0. And negative 8 plus 9 is 1. And so we have a diagonal matrix, which is great. So now to find a to the n, we're going to use basically this property here. So this is D. So what we have is that, p to the negative 1 AP equals D, and therefore A is P dP to the negative 1, if I just sort of multiply the left and the right by P and its inverse. And so a to the n is going to be P dP to the negative 1 to the power of n, which is going to be, if we expand all this out, I'll get P dP to the negative 1, P dP, so this looks like almost the same letter there, P dP to the negative 1 all the way through to the end. And what we'll see is throughout all of the middle, all of these things are all just going to be i's and pretty much disappear. And what we're going to end up with is n d's in the middle. And so I'm going to have my p, negative 3, 4, 2, and negative 3. And if I actually take this d to the power of n, it's just going to raise 2 to the n and 1 to the n, but I don't need to write that. And then my p to the negative 1 will be negative 3, negative 4, negative 2, and negative 3. And then we just need to kind of clean this up a little bit. So I'll get negative 3, 4, 2, and negative 3. And then I will multiply this diagonal through. So negative 3 times 2 to the n, negative 4 times 2 to the n, and then negative 2 and negative 3. And then now just finally multiply this out. So I'm going to get 9 times 2 to the n minus 8. It's going to obviously depend on n. And then for the other one, I'll get 12 times 2 to the n minus 12. And then negative 6 times 2 to the n plus 6. And negative 8 times 2 to the n plus 9. And that is going to be our product. It's messy, but it kind of should be because it's repeated multiplication.